Hello friends, today we are going to discuss the topic the differences between amino esters and amino amides, right? Okay, so we're going to discuss the topic differences between amino amides and amino esters. Okay, what are these amino esters and amino amides? They are nothing but local anesthetics, and this classification is based on the chemical structure. Okay, basically this is the classification of local anesthetics based on the chemical structure. Okay, if you ask about if you ask anyone about the examples of local anesthetics, what is the first local anesthetic they will say, and the most commonly used is lignocaine. Okay, they'll say about lignocaine, lidocaine, bupivacaine. Okay, but to classify this, okay, they'll say about cocaine also. So there are many things. So to classify this and to identify this, it is like a little bit tough just based on the name, right? Because everything ends with the term cane. So to differentiate this and to identify this, we have to understand the differences between these two, amino esters and amino amides, right? Okay, and there is a small what is it, a mnemonic like to identify this based on just by seeing the name also. So, and there are some exceptions also, so let's discuss that in detail. Okay, so first let's start tabular column. Okay, so let's write the features, right? Next, amino esters, next amino amides. Okay, so let's draw the tabular column. Okay, so let's draw the tabular column. Okay, so the first point let's discuss is about the stability. Okay, amino esters are relatively unstable in their solution. Okay, they're relatively unstable when the lignocaine, not exactly lignocaine. Okay, I'll discuss about that in later. Any what is it, local anesthetic, when amino ester local anesthetic is in a solution, they are relatively unstable, whereas amino amides solution, they are relatively more stable. Okay, and why they are more stable is because of the presence of methoxy group. Okay, because of the presence of methoxy group, these amino amides are more stable. Okay, so this is the first point. Amino esters, they are relatively unstable in solution, whereas amino amides are relatively stable because of the presence of methoxy group. Okay, so let's go to the second point. Yes, so the second point is metabolism. Okay, let's see about the metabolism. Let's just draw a small line. Okay, but it's not getting confused. Okay, let's see about the metabolism. Mainly these amino esters. Okay, mainly these amino esters are metabolized by plasma cholinesterase. Okay, these are metabolized by plasma cholinesterase. They don't need hepatic or renal excretion. They can be easily metabolized by the plasma cholinesterase, by the blood itself. Okay, so in blood itself they can be easily metabolized. Whereas aminoamides, they require the help of liver. So they are metabolized by hepatic metabolism. They undergo hepatic metabolism, right? Okay, but there is an exception. This is the main thing. In exams, in any exam for that sake, they usually don't ask that the examples directly. They ask the exception. So what exception is there in amino esters? You can easily remember the metabolism. It's like amino esters, no? So it is metabolized by esterase. So the exception here is cocaine. Okay, cocaine is the common example. Okay, cocaine undergoes hepatic metabolism. Okay, cocaine undergoes hepatic metabolism. Okay, whereas the exception here is articaine. Okay, articaine undergoes plasma cholinesterase. Okay, it's plasma cholinesterase metabolism. Okay, it is metabolized by plasma cholinesterase. It's just the reverse. Okay, right? Okay, so moving on to the next point. Let's go to the next point. Okay, I'll just draw the line. Okay, let's go on to the next point. So the duration of action. Okay, so what is the duration of action of both of these? The third point is duration of action. Okay, so amino esters, they are shorter acting, whereas aminoamides are longer acting. Okay, is there any exception for this? Yes, there is again an exception for both of these. Okay, so what is the exception? The exception is tetracaine. Okay, so tetracaine is an exception, so it is longer acting, and the same exception as previous we saw, that is articaine. Okay, articaine is again an exception. Okay, so let's move on to the next page. So next what we are going to see is the allergic reaction. Okay, let's see about the allergic reaction. Let's just draw the tabular column. Okay, so the next point you are going to see is the allergic reaction. It's the fourth point, right? Yes, so next we are going to see about the allergic reaction. Okay, allergic reaction. There is high incidence of allergic reaction in amino esters. Okay, there is high incidence of allergic reaction. Okay, why? Because of a metabolite named as PABA. Okay, metabolite. PABA is a metabolite. What is PABA? Para-amino butyric acid. Let's just what is GABA? It's gamma amino butyric acid. PABA is para-amino butyric acid. Okay, so next here in aminoamides, the allergic reaction is rare. Okay, so that's all. Allergic reaction, it is observed maximum in amino esters, and it is rare or minimal in aminoamides. Next we are going to see the examples, right? Let's see the examples. Okay, now let's go for the examples. Okay, how to remember this? Okay, first let's see here. What are the examples for aminoamides? First amino esters. We can see the examples of procaine. Okay, just write in a different thing. See, procaine. Okay. Okay, and at the last I will just name it, right. Just a second. I just first write it and then explain. Procaine. Next is chlorprocaine. Next is cocaine. Okay. Next is benzocaine. Next is tetracaine. Okay. Coming to aminoamides, let's see the examples. This is lidocaine. That's lidocaine. Next is mepivacaine. Next is prilocaine. Now prilocaine has high incidence of methemoglobinemia. Okay, because it produces a metabolite orthotoluidine. Let's discuss. If we discuss the topic, let's discuss it later. Okay. Next is bupivacaine. Next is ropivacaine. Next is dibucaine. There is something called as dibucaine number, if you remember, which measures the activity of pseudocholinesterase. We can discuss it later when time permits. Next is etidocaine. Last one is articaine, which is a common exception. Okay, it has shorter duration of action. And next one is, what is it? Is metabolized by esterases. Okay, so these are the what is the differences. Now how to identify it? Okay, so identification is important. So how to identify this? So that's an important thing you have to know. So let's see. Okay, if you see in amino esters, okay, amino esters, let's go to the previous pages. See, in amino esters, you can see there is only one I. Okay, sorry, I couldn't highlight it separately. Just one second. I'll just try to write it then. Okay, there is only one I basically. See, I'll just write it. I'll use a different color so that it will be easy. Amine. Again, yellow. I'll go to yellow. So that, see, okay, see, there is only one I, right, in amino ester, whereas in aminoamides, if you see, there are two I. Okay, there are two I. Okay, I'll just erase it and write so that it will be easier to understand. Okay, okay, so you can see that there is two I in it, right? See, aminoamides. So there are two I, right? So it's the same thing. You have to see in the examples also, these two things you have to see. See, see in this examples, this is amino ester, right? Why? Because in amino ester, how many I's are there? There is only one I, right? See, same way. Oh, it got highlighted here. Okay, just a second. Maybe it can got highlighted. Okay, no problem. I'll just erase it. I'll erase it and write again so that it's easy. Okay, so now I think it will be quite easy. See, in amino esters, there is only one I, right? See here, and here, see, there is only one I. right? See here, I'm trying to highlight it. Just a second. Yeah, see here, there's only one I. Okay, whereas in aminoamides, you can see that lidocaine, you can see that 2I, 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 2I. Dipicane also there, see, 2I, 2I, 2I. Okay, so if there is 2 I's, okay, if there is 2 I in the name, it is an aminoamides. There is only one I, it is aminoester. If there is only one I, it is aminoester. If there is 2 I, it's aminoamides. So using this, you can easily identify. So what we discussed now, let's go through a brief. In brief, so we saw the differences between aminoesters and aminoamides. So what is this aminoesters and aminoamides? They are like local anesthetics. The classification is based on chemical structure. When the local anesthetics are classified based on chemical structure, we get aminoesters and aminoamides. Okay. Next, see what are the differences. See, aminoester and aminoamides. First, the stability. Aminoesters are relatively unstable. Aminoamides are relatively stable. Okay, because of the presence of methoxy group. Okay. So because of the presence of methoxy group. Okay, next, metabolism. Aminoesters, as the name itself says, it is metabolized by plasma cholinesterases, and there is an exception, that is nothing but cocaine. Okay, it undergoes hepatic metabolism, and the same way aminoamides, it undergoes hepatic metabolism predominantly, but there is an exception, that is nothing but articaine. Okay, it is metabolized by plasma cholinesterase. Next is duration of action. Short acting. Okay, most of the things are short acting. There is an exception, that is nothing but tetracaine. Okay, and aminoamides, they are longer acting, and the same example, there is nothing but articaine. Okay, next, allergic reaction. There is high incidence because of a metabolite PABA, and there is rare incidence of this in aminoamides. Okay, and examples. So you can see procaine, chloroprocaine, cocaine. You know what's the first first local anesthetic to be identified? It is cocaine, and it is identified by, just a second. It is identified by whom? It is identified by a person named as Carl Koller. Right? Just an MCQ, remember it. And next, how to identify it? If there are one I, it's an aminoester. See, in aminoester also you can see there is only one I, and if there is 2 I, it is aminoamides. So that's all. So this is an important topic which everyone needs to know if you're going for any competitive exams. So that's all for today. Have a good day, guys, and see you in a new video. Thank you.